We still haven't proved what we wanted, though. We need to show that the limit from the right is different. Right? So there's our red slope. Now let's show the other one is different from 1. So we would now find the limit as x approaches x approaches 1 in particular for this problem. X approaches 1 from the right, and we would have f of x minus f of 1 over x minus 1, but this time we are to the right of this location. X is approaching 1 from the right, so therefore we are on the 3x minus 1 part of this curve, right? Even it says here x is greater than 1, we're to the right of 1, so we're on 3x minus 1. We are now on the linear portion here, so we need to reflect that in our choice of function rule down here. So this will become the limit as x approaches 1 from the right of the function is 3x minus 1 minus 3, 1 minus 1, the function with 1 plugged in, and that's all over x minus 1. Again, there should be some sort of algebra here that allows x minus 1 to vanish from the bottom, and it happens pretty quickly. We have 3x minus 3, and we have negative 1 plus 1 is 0. So we have 3x minus 3 in the numerator. Right. So you can factor it off to 3, just to cut to the chase here, and x minus 1 over the x minus 1. Factor canceling, we now have 3 as our answer, right? The limit doesn't affect that whatsoever. And that makes perfect sense because, again, it's a linear function. Of course, it had to be the slope itself of this same 3x minus 1 linear function. So our answer is 3. And that would be slope of blue. Okay. Blue slope. So again, as you approach 1 from the right of 1, you're always on this line 3x minus 1, so therefore the tangent slopes are always 3 itself. Even when it coalesces at this location, the slope is still 3 on the right. So since you have a slope of 1 on the left and a slope of 3 on the right of this particular location, so therefore the conclusion is limit as x approaches 1 from the left, f of x minus f of 1 for x minus 1 does not equal the limit as x approaches 1 from the right of that exact same expression, i.e. the two one-sided derivatives, right? The two one-sided derivatives are not the same. So therefore, f prime of 1 does not exist.